Kia ora, Year 10. In this video, I'm going to go through how to solve simultaneous equations using a method called substitution. And this goes with two really good exercises, one in the Walker workbook, which is on page 18, and there's a really good explanation on page 17. And then in the Gamma textbook, which is the old blue one we've got in the classroom, it's on page 124, and that's exercise 10.04. Okay, so in this video, I'm just going to look at simultaneous equations algebraically, and I'm going to look at examples that have just got x and y. What we're going to be doing as we get ready for the 1.4 internal is instead of working with x's and y's, we're going to be working with real life situations. But if we can do it first with the x's and y's, it'll be easy when we come to do the real life situations. So the two equations I've got here are kind of classic simultaneous equations. We've got two different relationships between x and y. The first one is that y is equal to 4 times x. And the second one is that x is equal to y take away 6. And what we're looking for is whether there is any combination of x and y that's going to make both of those equations true at the same time. Okay, so because we can see that we want to have this be true and this be true, we know that that will only happen if y is equal to 4 times a number. So to use this method called substitution, we want to have y is equal to blah, 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 or we want to have x is equal to blah, blah, blah. And we're going to take either one of those, and I'm going to do the y equals 4x, and we're going to substitute it into the other equation. So that's what I'm about to do now. So x is equal to not y minus 6, but 4x minus 6, right? I'm taking the y equals 4x from here and I'm replacing that y with 4x. So now we're back to the kind of equations we did last term. We've got x on both sides. We're going to subtract 4x from each side, and that will give me negative 3x equals negative 6. Now we divide both sides by negative 3 and we get x is equal to negative 6 divided by negative 3, which gives us positive 2. So we're not quite finished because we've got our x value, but we need to now get our y value. So we've got x equals 2, and we take it and we substitute it into this one here, and we get y is equal to 4 times 2, so y is equal to 8. And to finish it off, we write it like this: x, y is equal to 2, 8. Okay, so a second example, a little bit harder with slightly worse numbers, is this one. I'm going to do this one and a third example and then give you 3 to try yourselves. So in this equation, we've got x is equal to 15 minus 3y. So we like the fact that x is equal to blah, 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 because we're going to substitute that into my other equation. So you can see the first equation has got x's and y's kind of more mixed up, right? So it's got 4y plus 5x is equal to 42. But because this one is in the x equals form, we're going to take the x and substitute it, right? Now I'm repeating that a lot because I think when you start doing these, they're kind of weird, right? So let's get on with it and now do that substitution. So we're going to have 4y plus 5, but instead of x, we're going to have 15 take away 3y. Right, so it's 5 times all of this, and that's why I've put it in brackets, and that equals 42. So you can see that often with simultaneous equations, we have to do a whole bunch of steps that we learned in year 9 that at the time didn't seem that useful, but now we're using our expanding idea, right? So 4y plus 5 15s are 75, right? So expanding that, take away 5 times 3y, so take away 15y, is equal to 42. Okay, what does that give us? Well, we have to collect up our like terms. We get negative 11y plus 75 is equal to 42. I'm going to subtract 75 from both sides. I get negative 11y is equal to, so 42 take away 75 is negative 33. Now remember, you are allowed a calculator, right? So most of you will do that easily in your heads, but if you can't, you can just grab your calculator and check your calculations. We're nearly there. We've got negative 11y is equal to negative 33. So that gives me y is equal to 3, right? What am I doing for that last step? Well, I'm dividing by -11. Okay, but we're not finished. As before, we've got our y value, but we need to go all the way back and get our x value. So looking back at those two original equations, we can see that that x equation, this one here, is that x is equal to 15 minus 3y. Okay, so x is equal to 15 minus 3 times 3. So x is equal to 15, take away 9, which is equal to 6. Right, so that gives me my final answer here of x, y. Oh, I don't know why it's doing that. Let's just get rid of that. So x, y is equal to 6, 3. And we're going to go back and check that that works. So 4 times 3 plus 5 times 6 is equal to 12 plus 30, which equals 42. So it does work. So what I'm doing there is I'm substituting my answer values to check that it's okay. Okay, it's probably time that we got some steps down. So let's see how we're going to do these. Well, the first thing is to check if we've got x equals blah blah or y equals blah blah. And if we have, then we're good. We're going to take that and we're going to substitute whatever the x equals thing is into the other equation, right? Then we're going to clean up the mess. We're going to expand brackets and simplify like terms. And we solve the equation for the first variable. Then we use the equation from the top to get the second variable's value. And finally, we give our answer. So I'll do one more example before you try some. And this time I'm going to go a little bit faster. Okay, so we've got x equals 4y take away 1. We're going to substitute that in and we get 2 times 4y minus 1 minus y equals 26. 8y minus 2 minus y equals 26. 7y minus 2 equals 26. 7y equals 28. Y is equal to 4. Now we take the y value and we have to get the x value. So we take the y and we substitute it into here. X equals 4y minus 1. X is equal to 4 times 4 minus 1, which gives me 16 take away 1, which is 15. So xy is equal to 15 for x and 4 for y. Okay, 3 for you to try now. Here's the first one. So I'm going to show you the 3 questions. That's the first one. So pause the video and copy that one down. Here's the second one. Pause and copy it down. And here's the third one. So pause and copy that one down as well. Right, once you've had a go at them, then unpause the video and keep on watching. Okay, so here's the first one. We've got y is equal to 2x plus 4. So we know substitution will work. We're going to take that. We're going to substitute it in here. That gives me 3 times 2x plus 4. Take away x is equal to 12. 6x plus 12 minus x equals 12. Simplifying my like terms gives me 5x plus 12 equals 12. Or subtracting 12 from both sides, 5x equals 0. Dividing both sides by 5 gives me x equals 0. Okay, so what steps have I got here? Well, I'm taking away 12 from both sides there, and I'm dividing by 5 on both sides there. So that gets me down to the x equals 0, and now I take it and I plonk it back in to my first equation, and I get y is equal to 2 times 0 plus 4, which gives me y equals 4. So my answer is x, y is equal to 0, 4. On to the second one for you to try. So this time I've got x is equal to 6 minus 2y. I'm going to take that and substitute the x into here. 6 minus 2y minus 2y equals 10. 6 minus 4y equals 10. Negative 4y is equal to 4. Y is equal to -1. We take the y equals -1 and we substitute it back into here to get x. And we get x is equal to 6 minus 2 times -1, which is 6 plus 2, x is equal to 8. So my answer here is xy is equal to 8, -1. That's my final answer for that one. I just want to quickly go over the steps I did in here, because I did it quite quickly. The first step here is just my substitution step. Then here, what am I doing in that next line? I'm doing like terms. This time I'm subtracting 6 from both sides. And here I'm dividing both sides by -4. Okay, and lastly I'm taking my y and I'm substituting it back to get x. Right, the last one, y is equal to 8 minus x, so I'm going to take that and I'm going to substitute that into there. So 2x plus 3 lots of 8 minus x, have to put it into brackets, is equal to 25. 2x plus 24 minus 3x is equal to 25. Oh, that's hard to read. Let's fix it up. There, that's better. On this side, I've got -x, right? So 2x, take away 3x, -x plus 24 is equal to 25. I'm going to subtract 24 from both sides. That gives me -x is equal to 1. Finally, I get x is equal to -1. I take that and I substitute it back into there. So y is equal to 8 minus -1, which is 9. So x, y is equal to -1, 9. So that's my final answer for that one. Now, thanks for watching. That was a really long video, so you've done really well if you've got right through to the end. Make sure you do tons and tons of practice at these. So the Walker Workbook, page 18, or Gamma 10.04.